Hello students, this is our part 2 session in the chapter Nuclei. As you know that in my previous class I was discussing about the introduction part and some of the topics of this chapter, and with respect to that all the basic ideas, now we shall continue the further topics of this chapter. But before continuing this topic, just we have to go for the some concepts. We have to flashback all the details what we have studied in our previous class. See, in the previous class I was discussing about nucleus, composition of the nucleus, and in composition of nucleus, I told you that nucleus is composed with protons and neutrons. Protons are nothing but the positively charged particles, whereas neutrons are nothing but the what electrically uncharged particle or whose charge will be zero. And the number of protons in the nucleus will decides its atomic number, and the total number of protons and neutrons in the nucleus will decides its mass number. That is nothing but the what nucleons. Collectively protons and neutrons are called nucleons. The presence of nucleons in the nucleus will decide its atomic mass number, and thereby we defined about the what isotopes, isotones as well as isobars. So due to the variation of proton and neutron number, it leads to the what the same element, it leads to the some isotope formation, some isobar formation, and some isotone formation. So due to the variation in protons or due to the variation in the neutrons, so it leads to the what formation of some same nuclei, some different properties. So some are having same chemical properties but different nuclear properties. Some are having same nuclear property but different chemical properties, like that. So next after this I discussed about the size of the nucleus, as particularly size of the nucleus. While discussing size of the nucleus, I told you that the size of nucleus is mainly depends upon the what presence of number of protons and neutrons in the nucleus. In general, it depends upon the atomic mass number. So thereby we noticed that the naturally the which is the smallest nucleus in general, the smallest nucleus is nothing but hydrogen, as particularly proton of one of the isotope of hydrogen, that is proton 1H1, which possesses the smallest radius about 1.2 Fermi. And even we observed that uranium is nothing but the what an element which possesses the biggest, or that is the largest radius of its nucleus, that is around 8 Fermi. So like this we discussed some concepts related to the nucleus. And for the present class, what we are going to discuss means, we are going to discuss for the present class, that is nuclear mass and nuclear density. We are discussing nuclear mass and nuclear density. So what is a nuclear mass? Generally, the mass of the nucleus is going to be expressed in some specific units, and that specific unit we are going to call it as what? The atomic mass unit. Generally we call it as atomic mass unit. So mass of the nucleus is nothing but the nuclear mass, and this nuclear mass we are going to express even in terms of kg also, but more specifically we are going to express this unit in terms of atomic mass unit. So we are going to express this in terms of atomic mass unit. So what is an atomic mass unit means? So we have a definition here, atomic mass unit. So this atomic mass unit is used for expressing the mass of the nucleus, and it is the specific unit we are going to mention while expressing the what the mass of the nucleus, or while expressing the nuclear mass. So therefore here atomic mass unit. So what is this atomic mass unit? What is atomic mass unit? Generally one atomic mass unit is defined as 1 by 12 mass of an 1 by 12 mass of an atom of carbon 12. So what is that? One atomic mass unit. What is atomic mass unit? It is the representation, it is the specific unit representation for the measurement of nuclear mass, and it is expressed in terms of atomic mass unit. And that one atomic mass unit is equal to what? 1 by 12th mass of an atom of carbon 12. So 1 by 12th mass of an atom of carbon. So one atomic mass is defined as what? 1 by 12th mass of an atom of carbon 12. So this definition I am going to write it in an expression manner, that is one atomic mass unit. In general we write it as 1 AMU, and even we are going to represent 1 AMU, or even we use the letter U, small u. So therefore one atomic mass unit is equal to what? 1 by 12, 1 by 12 mass of an carbon 12, 1 by 12 the mass of an atom, mass of an atom of carbon 12. So it means mass of proton or neutron, not mass of proton or neutron, sorry, mass of an atom of carbon 12. So generally mass of an atom of carbon 12 means mass of one atom of carbon, one atom of carbon 12 divided by 1 by 12. See here, 12 is nothing but the mass number. So it means generally I want mass of one atom of carbon 12. So mass of one atom of carbon 12 means I don't know in 12 grams of carbon how many number of atoms are there. So generally there are 6.022 into 10 raised to 23 atoms are there in 12 grams of carbon. Therefore mass of one atom, therefore mass of one atom of carbon 12 is, that is 12 divided by 6.022 into 10 raised to 23. That should be equal to what? 12 divided by 6.022 into 10 raised to 23 is equal to what? Mass of one atom of carbon 12. Therefore, see, one U is equal to, or one atomic mass unit is equal to, what is mass of an atom of carbon? One atom of carbon, that is 12 by this much. So therefore, 1 by 12 of 12 divided by 6.022 into 10 power 23. So if I simplify, 1 U is equal to, what I am getting here is 1.66 into 10 to the power of minus 27 kg. So one atomic mass unit means nuclear mass. One atomic mass unit, that is a nuclear mass, is equal to 1.66 into 10 power minus 27 kg. And this value 1.66 into 10 power minus 27 kg is nothing but mass of a proton or mass of the neutron. So next concept after the nuclear mass, we have nuclear density. So what is nuclear density? So nuclear density is commonly how we are going to define density. In the same way we are going to define here nuclear density as nothing but nuclear mass per unit volume. We are defining density as mass per unit volume. In the same way we are going to define nuclear density as nuclear mass, instead of mass, nuclear mass by unit volume. So that is our next topic, nuclear density. Next topic is nuclear density. So you are getting these all calculations, concepts in your textbook. So try to note down and try to go through that. possible. And next we shall go for nuclear density. So what is nuclear density? It is represented with the letter O, and it is defined as nuclear mass, nuclear mass, nuclear mass per unit volume, nuclear mass per unit volume is called nuclear density. So it means nuclear density, nuclear density rho is equal to mass of nucleus, mass of nucleus divided by volume of nucleus, volume of nucleus. We know that mass of the nucleus is represented with the what? Letter A. So if I multiply that letter A with respect to mass of a proton or mass of a neutron, I am going to express this mass of nucleus in terms of atomic mass unit. Therefore, mass of proton or neutron into A. In general, I am taking the element having the mass number A. If I multiply with mass of a proton or neutron, I am going to express that mass in terms of AMU. So volume of the nucleus. Listen here, volume of the nucleus is nothing but the water. Volume of the nucleus is 4 by 3 pi r cube, where r is the radius of the nucleus. And we know that r is equal to r naught a to the power of 1 by 3. So in place of r, if I substitute r is equal to r naught a to the power of 1 by 3, what it becomes? V is equal to 4 by 3 pi, what is r? R naught a power 1 by 3, R naught a power 1 by 3, its whole cube. So this become R naught cube and a power 1 by 3 whole power 3, 3 get cancelled. So volume becomes 4 by 3 pi R naught cube into a. So it means here 4 by 3 pi R naught cube into a. So here a get cancelled. So therefore, nuclear density rho is equal to mass of a proton or neutron 1.6 into 10 power minus 27 kg divided by 4 by 3. Say 4 by 3. 3 should be taken to numerator. So therefore, rho is equal to 3 into 1.66 into 10 power minus 27 upon 4 into 3.14 into R naught 1.2 into 10 power minus 15. Don't forget R naught is the proportionality constant between the atomic mass number and radius of the nucleus, and we treated that R naught as what? We treated that R naught as nothing but the what? The one of the innermost radius of the nucleus, and it is innermost. Nucleus means it is the innermost only, but the smallest nuclear radius. Yes or no? It is the smallest nuclear radius corresponding to the atom of hydrogen, corresponding to the hydrogen atom. So therefore, here rho is equal to this much value I am going to get. So this is R naught cube. So now what I am going to write, if I simplify this rho, what it becomes if I simplify this rho? Rho is equal to, ನೀವು ಇದಿಷ್ಟು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಸೊ ಆ ವ್ಯಾಲ್ಯೂ rho is equal to 2 point something, you are getting that value. That's 2.38 into 10 raised to minus, sorry, 10 raised to 17 kg per meter cube. It means once if you look at this value, the density of the nucleus is almost 10 to the power of 14 times greater than that of the water, and hence nucleus is nothing but the water, a highly compact, and it is in a compressed condition inside the atom, and even it is nothing but the water independent of atomic mass number. Nuclear density is not depends upon the atomic mass number. Whatever may be the atomic mass number of that particular nuclei, but the density of the nucleus remains same. Almost it is 2.38 into 10 to the power of 17 kg per meter cube only. It remains the same. Therefore, nuclear density is independent of water, atomic mass number or nucleons, and it is same for all the nucleus of an different elements. So after this, next concept is Einstein's mass energy relation. What is the next concept? Einstein's mass energy relation. Next we have Einstein's mass energy relation. We have Einstein's mass energy relation. So what we are going to discuss in this topic means, see, from special theory of relativity, Albert Einstein proposed the what? One equation, and that equation relates the energy as well as mass. And according to this equation, the energy and mass are nothing but interconvertible. It means mass can be converted into energy as well as energy can also be converted into mass. So what is that equation, or what is that mathematical form of that conversion of energy into mass or mass into energy means? So that equation is nothing but what? E is equal to mc square, where m is nothing but the what? Mass, and c is the speed of light in vacuum, where c is speed of light in vacuum. It means this is an equation for energy equivalent to mass. It means energy is equal to mass with respect to the water, the speed of light, that is mc square. According to this equation, the energy can be converted, or energy can be expressed in terms of mass, and mass can also be expressed in terms of energy, and we can convert energy into mass as well as mass into energy. Remember, we can also convert this energy into different forms of other forms of energy such as kinetic energy, and also we can convert this as what? One of the mechanical energy, that is kinetic energy, into the what? Mass. So therefore, this equation will gives you an idea the conversions of energy into mass as well as mass into energy, and even conversion of energy into some another forms of energy also, as particularly in case of nuclear and elementary particle interactions. In case of nuclear and elementary particle interaction. So what is this elementary particles? The elementary particles study is nothing but the what? So complex one, and you are going to study this one in your higher level studies. So elementary particles means we have some classification for subatomic particles for protons, electrons and neutrons. There are some subatomic particles and there is a one classification, and all those subatomic particles we are going to refer as some elementary particles. So in case of nuclear and elementary particles, we are observing the what conversion of energy into mass and mass into energy which takes place. And remember, while taking these elementary particle interaction, we are going to apply law of conservation of energy. And along with law of conservation of energy, we have to consider the water masses into the consideration. Not only energy should be taken into the consideration, simultaneously mass is also taken into the consideration while converting mass into energy. So one simple example I am going to give you for the experimental verification of this Einstein's the mass energy relation. One simple example: if you take a positron, it is an antiparticle of electron having the same mass, but the charge is opposite to that of electron. The positron carries positive charge. When such a positively charged positron and antiparticle of electron as well as electron, if they brought close to each other, what happens? They destroy, they get annihilate. They get annihilate. So what is this annihilate? So annihilate means they destroy each other. So if particles are destroy each other means their masses can not be destroyed here. That mass is indirectly converting as a energy. It means if they annihilate, after the annihilation, mass is get converted into energy, and according to Albert Einstein, what type of energy after the annihilation they emit means they are emitting the water gamma ray. They are going to emit the water a gamma ray, which is also one of the water radioactive ray, and they are going to emit the gamma ray of some particular energy around 1 million electron volt or some more than this, nearly, which is 1 million electron volt or 1 mega electron volt. It means in case of annihilation, we call this process as annihilation. So what is annihilation? Annihilation is nothing but the what? It is the process in which the positron and electron will come close each other and they destroy, but their mass get converted into energy and it emits the gamma radiation or gamma ray of energy 1 million electron volt. This type of process we call as what? Pair annihilation. We call this process as what? Pair annihilation. Annihilation. And this process is reversible. We can also reverse this process. So in case of pair annihilation, we observe that positron and electrons are coming close to each other, thereby they destroy each other, they annihilate each other, but their mass converted into energy, gamma ray of energy. Now I am going to take this gamma ray energy. Suppose if I take close to the nuclei, some heavy nuclei, is it possible to get back the same positron as well as electron? Yes, definitely it is possible and it is experimentally verified. Such process we call as what? Pair production. We call such process as what? Production. Pair production. And even another one example I would like to give you for the validity of this Einstein's mass energy relation. In case of nuclear fission, working of nuclear bombs or atomic bombs, the atomic bombs are working based on the fission reaction phenomenon. And what do you mean by fission? You know that the splitting up of heavy nucleus into its constituent nucleus or two lighter nucleus by emitting some amount of energy. Do you know why they emits the energy? Because compared to the what parental nuclei, here the mass of the daughter nuclei will be less. compared to that. So decrease in mass happens, but this decrease in mass indirectly or it is converted as energy. Indirectly it is converted as energy here. So decrease in mass is converted as energy. So it means the conversion of energy into mass or conversion of mass into energy is possible, and we are observing this in case of some radioactive phenomenon and in case of nuclear and elementary particle interactions. So this is the one idea how to convert energy into mass or mass into energy in case of nuclear phenomenon, and it comes under this concept of nuclei, and this idea was revealed by the person Albert Einstein. And the next concept of this topic is energy equivalent to one atomic mass unit. Generally we know that the mass can be converted into energy and energy can also be converted into mass according to the Albert Einstein's theory of relativity. So we know that the one atomic mass is equal to 1.66 into 10 power minus 27 kg. Suppose if such mass is subjected for energy conversion, what will be the energy emitted by such a mass of a proton or mass of neutron? That we are going to discuss in the next concept, that is energy equivalent to one atomic mass unit. So it means how much energy is associated with the one atomic mass unit. Energy equivalent to 1 AMU. So how to express or how to calculate energy equivalent to one atomic mass unit? So we know that from special theory of relativity, Einstein proposed an equation, that is E is equal to mc square. According to this equation, where c is speed of light and m is nothing but the what atomic mass unit. So we know that one atomic mass unit is equal to 1.66 into 10 raised to minus 27 kg. And what is c? Speed of light in vacuum. This is 3 into 10 to the power of 8 meter per second. Therefore, energy becomes what? 1.66 into 10 to the power of minus 27 into 3 into 10 to the power of 8 whole square. Suppose if you calculate this, you are going to get the what answer in terms of joules, and you are going to get this in terms of joules. This is in terms of joules. Suppose if you divide this value by 1.6 into 10 raised to minus 19, because I want to express in terms of electron volt. So therefore, energy becomes 931. Nearly energy will be equal to 931 million electron volt or mega electron volt. 10 to the power of 6 is read as mega or million electron volt. That is 931 million electron volt. In some of the book it may be given as 931.3 also. 931.3 million electron volt. 931.3 million electron volt. Very simple. Mass, I am taking one atomic mass unit, that's 1.66 into 10 power minus 27 kg. Multiply this with speed of light, 3 into 10 power 8 whole square, in vacuum it is, divided by 1.6. Why I have to do? Because I am getting this value in terms of joules. If I divide with the charge of electron, then I am going to get the what energy in terms of electron volt. So therefore, this is the energy equivalent to one atomic mass. So it means one atomic mass can have a capability of generating the energy 931.3 million electron volt. Is it clear? So this is our today's class. And in my next class, I am going to continue the topic of mass defect and binding energy. Just you can go through this chapter. If possible, if you make a note of this concept and you try to write the notes, wherever you find difficulty or doubts, you can come to college and you can ask your doubts and just you can have a clarification for this. Is it clear? So just you can go through this chapter and you read this topic once again from the textbook also if you find any doubts or difficulties. So you are unable to clarify your doubt means you can come to college and you can ask your doubts at any time. Is it clear? So thank you.